Welcome to Spaceverse, your portal to cosmic adventures. Mars has made a revolutionary discovery by revealing a massive underground water reservoir. A wonderful discovery that is altering the way we think about the red planet is that scientists have discovered a large subterranean store of liquid water on Mars. This is a discovery that has changed that way. Due to the enormous size of this reservoir, it has the potential to contain sufficient water to cover Mars to a depth of approximately 1 to 2 kilometers, which is approximately 1 mile. Scientists have been perplexed for a considerable amount of time regarding the question of what happened to all of the water that was once there on Mars. However, this discovery finally puts an end to their speculation. The context of the prehistoric period on Mars. The dry and bleak environment that Mars is now is the result of Mars's evolution. In point of fact, Mars was a planet that was far more human-friendly many eons ago. When Mars was younger, its atmosphere was denser and its climate was warmer, which allowed liquid water to flow freely across the surface of the red planet. There are a number of pieces of evidence that point to the likelihood that Mars used to be a planet that was more active and had more precipitation. The evidence comes from the outflow roads and valleys on Mars. One of the most important pieces of evidence that suggests that there was water activity on Mars in the past is the existence of extensive networks of valleys and outflow canals. These structures are very comparable to the river deltas and valleys that can be found on Earth. Similar to the rivers that exist on Earth, these canals on Mars demonstrate that the surface of the planet was initially sculpted by the movement of liquid water, which deposited sediments and left behind channels. Given the striking similarities that exist between the valleys of Mars and the river systems on Earth, it is indisputable that water played a significant role in the formation of the terrain on Mars. For instance, the Valles Marineris Canyon system, which stretches for more than 4,000 kilometers, 2,500 miles, and falls to depths of up to 7 kilometers, 4 miles, is a good illustration of the immense magnitude of the erosion that has occurred on Mars. If there was ever sufficient water on Mars to build such huge and intricate landforms as these valleys demonstrate, then that time has long since passed. The process of locating minerals that are hydrated. The discovery of hydrated minerals on Mars is a significant piece of data that adds additional support. Minerals such as clays, sulfates, and certain salts can only form when water is present in the composition of the environment. Both Curiosity and the Mars Reconnaissance Orbiter, which are both rovers, have found these minerals all over the surface of Mars. One of the most compelling pieces of evidence that water played a significant role in the history of Mars is the occurrence of hydrated minerals. An example of this would be the clays that were discovered by the Mars Curiosity rover in Gale Crater. These clays indicate that there was liquid water present in the past. These clays are formed as a result of the chemical transformation that occurs in volcanic rocks when they are exposed to an environment that is abundant in water. The fact that sulfates can be found in a number of different areas on Mars lends credence to the notion that these minerals originated as a consequence of the evaporation of water. Sedimentary rock formations have been observed by rovers operating on Mars. The discovery of sedimentary rock formations by rovers on Mars constitutes a third piece of evidence presented by the researchers. There are similarities between the features of these rocks and those of rocks that were formed by the water on Earth. To give just two examples, ripple marks, which are caused by moving water, and cross-bedding, which takes place when water flows across sediment, are both characteristics that are frequently found in layered rocks. It is clear from these geological features that water played a significant role in the formation of the surface of Mars. These sedimentary rocks, particularly the ones that include ripple patterns and cross-bedding, lend support to the hypothesis that flowing water is present on Mars at some point in the past. It is possible to observe rock formations that are comparable to those found in the riverbeds, deltas, and lake beds of Earth, which suggests that Mars went through the same process when it had liquid water to begin with. A history of tragic transformations that occurred on Mars. Mars, on the other hand, was subjected to a series of catastrophic occurrences that radically altered its ecosystem and climate approximately 3 to 4 billion years ago. There was a significant event that took place when the magnetic field of Mars collapsed. The magnetic field of Mars was destroyed at a young age, in contrast to the enormous global magnetic field of Earth, which is produced by a dynamo action in the molten core of the planet. Our planet's magnetic field acts as a shield, protecting the atmosphere of Earth from the solar wind, which is the continuous discharge of charged particles from the Sun. The atmosphere of Mars was not protected by a magnetic shield, therefore it was subjected to the relentless bombardment of solar wind. Mars experienced a precipitous drop in atmospheric pressure as a consequence of the gradual loss of atmosphere that was brought about by the solar wind. As the thickness of the Martian atmosphere decreased, the likelihood of liquid water remaining on the surface of Mars became increasingly precarious. Both the process of evaporation and the journey into space began with water that was maybe liquid at one point in time. Additionally, the thinning of the atmosphere, which resulted in a reduction in the greenhouse effect, had a significant impact on the cooling of the atmosphere. As a consequence of this, the climate of Mars shifted from one that was warm and humid to one that is cold and dry, as we continue to witness today. The leftover water turned into ice on the surface or in the permafrost that was located beneath the surface. As we delve more into the mysteries of water that is missing, even with all of these adjustments, there was still something that was not quite right. According to our hypotheses, Mars ought to still have a sizable quantity of water on its surface, even after taking into account the water that is lost to space. The frozen water that can be discovered in the polar ice caps is not sufficient to provide a satisfactory explanation for the massive volume of water that was formerly present. The mismatch between the two locations sparked the curiosity of the riddle of where the remaining water on Mars could be hiding. If it is still there, has it ever occurred to you that it could be able to support life as we know it? With the InSight mission, NASA has made a significant discovery. The answer to this mystery was found by the NASA InSight lander, which was developed with the purpose of investigating the interior structure of Mars. In contrast to past missions that solely investigated the surface of Mars, the InSight mission was able to investigate the interior of the Martian crust in order to gain a better understanding of its internal composition, seismic activity, and heat transport. The InSight spacecraft was able to detect more than 1,300 earthquakes on Mars during the course of its 4-year mission. The seismic waves that were produced by these earthquakes, which were in turn driven by the impacts of meteors and volcanic activity, provided scientists with the opportunity to investigate the interior of Mars. Within these seismic waves, an enormous reservoir of liquid water was discovered, which came as a complete surprise. It is possible to draw parallels between the technology that was applied to find this reservoir and the methodology that is utilized to investigate the inner workings of our own planet, Earth. The behavior of seismic waves as they travel through different substances can provide scientists with information that allows them to infer the characteristics of the materials they research. A mathematical model of rock physics was utilized in order to find the water supply on Mars. This model is the same kind of model that is utilized in order to map underground oil reserves and aquifers on Earth. In accordance with the hypothesis, seismic data would be most accurately explained by the presence of a layer of broken igneous rock beneath the surface of Mars, with the cracks being filled with water. Igneous rocks and their role in water retention are the subject of this scientific study. The formation of igneous rocks occurs when molten rock, such as magma that is found beneath the surface of the Earth or lava that is found on the surface, cools and solidifies. Over the course of their cooling process, igneous rocks have the potential to develop cracks and fractures. It is possible for water to seep in and gather in the fissures created by these breaches if they are large enough. The passage of time may cause these fissures to become larger as a result of weathering, which will allow even more water to enter. Under some conditions, igneous rocks are capable of retaining water, despite the fact that they do not possess porosity and do not have the ability to do so. Understanding the water cycle on Mars has advanced significantly thanks to the discovery of a large underground water storage facility in the igneous rocks of Mars. This discovery has been a significant step forward, due to the fact that it is submerged at depths varying from 11.5 to 20 kilometers, 7 to 13 miles. It is unfortunate that neither the technology that is currently available, nor that will be developed in the future, nor astronauts will be able to access this layer of water. Even on Earth, drilling to those depths would become an incredibly challenging endeavor. What are the potential repercussions for life on Mars? There is a possibility that there is no life on Mars simply due to the presence of liquid water on the planet, yet the possibility surely presents some intriguing concerns. There is a possibility that the conditions that exist within this underground reservoir are comparable to those that exist in the deepest mines on Earth or on the ocean floor, both of which are environments in which bacteria thrive. The majority of the scientific community is of the opinion that any locations on Mars that have the potential to be habitable would most likely be established underground. As a result of this new discovery, we need to have an understanding of Mars' water cycle in order to determine whether or not the planet might support life and how its temperature has evolved over the course of time. There is a possibility that the subsurface of Mars contains the secrets of any life that has ever been on the red planet or may ever have existed there. In the future, there will be exploration of Mars. Following the discovery of a massive water reservoir on the red planet, there has been a resurgence of optimism for the future of Mars. There is still a long way to go before Mars can be considered a habitable planet, but the discovery of water somewhere on Mars opens up new doors for research. Because water is necessary for human survival, it is possible that future expeditions to Mars will be dependent on the presence of this reservoir. Human pioneering is met with a number of challenges. However, there are still significant challenges that need to be conquered before humans may explore Mars and potentially make use of this water supply. The protracted and challenging nature of the journey to Mars is a significant barrier. Mars is generally situated at a distance of approximately 225 million kilometers, 140 million miles from Earth. Taking into account the amount of time spent in flight, the amount of time spent on the planet, and the amount of time spent returning to Earth, a mission to Mars would take around 18 to 30 months to complete. It would be necessary for astronauts to have a sufficient amount of supplies for a journey of this length. Because of the distance, there would be a delay of several minutes in communication with Earth, which would make it impossible to receive prompt assistance in the event of an emergency. Radiation exposure is another important concern. Astronauts face significant health hazards due to the presence of solar particles and cosmic radiation in space. Mars does not have the protective magnetic field that shields Earth from much of harmful radiation. Thus, the risk of cancer and other health problems, as well as increased radiation exposure, would increase for astronauts during their voyage to and while on Mars. Additional obstacles are brought about by Mars' hostile climate. Even in the middle of summer, surface temperatures can drop to minus 125 degrees Celsius, minus 193 degrees Fahrenheit at night, and barely reach 68 degrees Fahrenheit, 68 degrees Celsius during the day. In addition, dust storms are common and occasionally even planet-wide, and they can last for weeks or months, which can damage equipment and interrupt solar power output. A major obstacle is the need to protect astronauts and their equipment from these extremely harsh conditions. Reliable life support systems that supply Mars with oxygen, water, and food are essential for human survival on the red planet. Mars has an extremely thin atmosphere that is primarily carbon dioxide, with no oxygen and nearly no water that can be reached by humans. Therefore, sophisticated machinery is required for oxygen generation, water recycling, and food production on Mars or the transportation of adequate supplies. Because of the extreme dangers of the Martian environment, these systems must be very reliable. Lastly, there is the issue of taking care of one's mental and physical health. Muscle atrophy, bone density loss, and other physical health concerns can result from prolonged exposure to microgravity throughout the flight. We don't yet know how the human body will react to Mars' reduced gravity, which is approximately 38% of Earth's. Another big worry is the mental toll that such a mission would take. Stress, anxiety, and despair may set in among the crew due to the extreme separation from Earth, as well as the stifling confinement conditions. Maintaining the emotional and physical well-being of the astronauts during the trip calls for meticulous preparation, continuous assistance, and creative approaches. Additional consequences and possible outcomes. A huge step forward in our knowledge of Mars has been made with the finding of its subterranean water reservoir. It paves the way for more exploration, which could lead to the use of this resource. Although landing humans on Mars is still a long way off, finding water there opens up new avenues for investigation. A sample of lunar soil successfully returned from the moon's far side recently generated news for China. China has a good chance of becoming the first country to set up a permanent facility on the moon if their series of missions continues to be successful. This new development exemplifies the fast-paced nature of space research, which is opening our eyes to exciting possibilities for the future of humankind beyond Earth. As we continue to explore and learn more about Mars, the discovery of a massive underground water reservoir serves as a reminder of the exciting possibilities that await us. The red planet holds many secrets, and with each new discovery, we inch closer to unraveling the mysteries of our cosmic neighbor. Mars has so much to offer, and the recent finding of a huge underground water reservoir is just one more reason to keep exploring and learning more about the red planet. We are getting closer to understanding our cosmic neighbor, the red planet, and its countless secrets with every new discovery. A heartfelt thank you for being here with us today as we come to the end of our journey at Spaceverse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.